Alrighty, so we're gonna continue on to, so this is section, again, I keep saying that this is a really long one. This is 7 section point 4, partial fractions. And I don't even remember which part this is. So this is part 7, it would seem. So we have a couple more examples to go through, and they're all examples of different things. The good news is this first example is a quick one. So we want to find the form of the partial fractions decomposition of, so we have x cubed plus x squared plus 1 divided by x minus 1, x squared plus x plus 1, and x squared plus 1 square cubed. Alrighty. So kind of just taking a step back. So the only term that's going to give us trouble here is this one. So this is an irreducible term to the third power. So just like in the previous example where we had, we had to include all powers of that term. Let me do an aside because I don't want to restart this video. So if we have something like 1 over ax squared plus bx plus c to the 5th power, the partial fractions decomposition of this is going to look like, and as long as this is irreducible, be ax plus b over ax squared plus bx plus c plus ab cx plus d over ax squared plus bx plus c squared, and we're going to keep doing that up to the 5th power, and I don't know which letters of the alphabet will be on. Let's assume it's g x plus h over ax squared plus bx plus c to the 5th. Okay. So that'll be the form of the partial fractions. It's just like what we saw with reducible linear terms. You just include one of every power. So I'm going to kind of cheat here. I'm going to move this down beneath it. So the notes will look strange, but it's fine. All right, so we want to find the partial fractions decomposition of this one. So like I said, this one is an easy problem. So I just go through and I look at each term. So for the x term, I'm going to get an a over x. For the x minus 1 term, I'm going to get a b over x minus 1. For this first irreducible term, so you can check that's irreducible, the b squared minus 4ac is going to be 1 minus 4, which is negative. So this is going to be of the form cx plus d over x squared plus x plus 1. And the last term is going to be the one that's going to be, the ones that are really annoying. So I have ex plus f over, so ex plus f over x squared plus 1 plus gx plus h over x squared plus 1 squared. And I get one more, so h I x plus j over x squared plus 1 cubed. And this is the form of my partial fraction. So let me, instead of actually doing that, I'll make this a little larger. So I can include that term. So we have h ix plus j over x squared plus 1 cubed. So that'll be the form of our partial fractions. That's all this problem is. So I'm going to just leave it at that. So the big point was, I had this irreducible term. So I get 3 terms, 1 for each power of that irreducible term. So I have 3 powers of the irreducible term on the left-hand side. So I get 3 different terms, each with a different power. So let's do another example. So we want to evaluate the interval 1 minus x plus 2x squared minus x cubed divided by x times x squared plus 1 squared. And I didn't really point it out, but the degree of the denominator on the example above is definitely way larger than the degree of the numerator. So the degree of the denominator is 6 plus 2 plus 1 plus 1. So that's 8 plus, so it's 6, 8, 9, 10. So the degree of the denominator in that one is 10. The numerator was 3. This one, the degree of the denominator is 4 plus 1 is 5. So we're good there. We can jump right into partial fractions here. So what we're going to do is we're just going to set it up. 1 minus x plus 2x squared minus x cubed over x times x squared plus 1 squared. We do the partial fractions. First one is just that a over x. Second one is bx plus c over x squared plus 1. And I also have to include that last power for the x squared. Put everything over a common denominator. So I get 1 minus x plus 2x squared minus x cubed divided by x times x squared plus 1 squared. This is going to be equal to common denominator for this one. A gets an x squared plus 1 squared. This bx plus c term gets one term from the x and also needs one more x squared plus 1. And then this last term already has 2x squared plus 1s. So it's just going to get an x over x times x squared plus 1 squared. So the denominators need to match here. And we're able to cancel them out because of that. So what I'm going to be left with is 1 minus x plus 2x squared minus x cubed. It's going to be equal to a. I'm going to go ahead and expand these. So on the right-hand side, I'm going to get x to the 4th plus 2x squared plus 1. And then, oh boy. So we're going to get plus x times bx cubed plus cx. Bx cubed. Yeah, so this is weird. So bx cubed plus bx plus cx squared plus c. I'll give myself a little more room. And then I have plus dx squared plus ex divided by, nope, sorry, I've already done the division. I've already done the division there. Gotten rid of that. Yeah, so we're going to keep going. So we have 1 minus x plus 2x squared minus x cubed is equal to a x to the 4th plus 2a x squared plus a plus b x to the 4th plus b x squared plus c x cubed plus c x plus d x squared plus e x. Now I'm going to collect terms in my polynomial. So look at all my x to the 4th terms. I have 2 of them. I'm going to get x to the 4th times a plus b. Looking for my x cubed terms, and it looks like I only have 1 of them. So I just have a cx cubed. So that takes care of that one. Now my x squared terms, I have 1, 2 there. So I'm going to have x squared times 2a plus d. My linear terms, I just have 2 of them. I have x times c plus e. And my constant terms looks like just a, right? Yeah. So yeah, so this is kind of an ugly one. But now I just equate coefficients. So on the left-hand side, I don't have an x to the 4th, so it's a coefficient of 0. It's equal to a plus b. The x cubed, so on the left-hand side, it's -1. The coefficient on the right-hand side is c. Coefficient for x on the left-hand side is, again, -1. Yeah, sorry. So x, hang on. So sorry, for x squared, it's 2. The coefficient on the left-hand side is 2. On the right-hand side, it's 2a plus d. The coefficient of x on the left-hand side is -1. On the right-hand side, it's c plus e. Constant term on the left-hand side is 1. Constant term on the right-hand side is a. Okay, so this is where I say, you guys get to do this. I don't think this one is too hard. But when you do this, you're going to get the solutions a equals 1, b is equal to -1, c is equal to -1, d is equal to 1, and e is equal to 0, it looks like. That's great. So now we can take all these terms and plug it back into, this right here. So let's do that. So what I'm going to be left with is, so I have 1 minus x plus 2x squared minus x cubed divided by x times x squared plus 1 squared. This is going to be equal to, so if I plug in all those constants into my partial fractions, there's too much to really go up and see, but you're going to end up with 1 over x minus x plus 1 over x squared plus 1 plus x divided by x squared plus 1 squared. Now the point is I can do this, I can do these integrals. So I'm looking for the integral of the right-hand side, 1 over x minus x plus 1, x squared plus 1 plus x over x squared plus 1 squared dx. Break this up into 3 integrals. Sorry, we're going to break it up into 4 integrals. And this minus sign is in front of the x plus 1. So when I split it up over those 2 integrals, I'm going to get minus signs in front of both of them. So I'm splitting up the middle term right now. This is x over x squared plus 1 dx. And then I also have the integral 1 over x squared plus 1 dx from the plus 1 term, but it has a minus sign in front of it. And then the integral x over x squared plus 1 squared dx. So now each of these is doable. ln of the absolute value of x, this one we've done a couple times. This is ln of x squared plus 1. You can do that in your head, great. If not, you need to do a u substitution. This third one here, that is our arctan integral. A squared is 1, so a is 1. So this is just arctan. Actually, this is just arctan of x. We know that one. And the last one, again, is a u substitution. If you can do it in your head, great. This is 1 over 2 times 1 over x squared plus 1 there. And you get a minus sign in front of it now, plus your integration constant. And that is that. This is one of those worst case scenarios. This is a lot of letters flying around. So go through this slowly. It is just partial fractions. It's just a lot of algebra, simplifying things. It's not too bad though. So I'm going to stop this video here. I have one more. So I'm not going to get it uploaded at the same time I get all the other ones uploaded. So if you're watching these early, there's going to be 8 parts to this, to the YouTube videos. So be careful of that. I'm going to get this up, or the last part up, as soon as I can. I'm going to stop this here.